system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
So I'll extend this because we will be required. So first, whenever a diagram given, immediately convert this diagram to this. Here if you see, this is a cantilever beam. Cantilever beam means obviously there will be reaction forces. Here already moment, one extra moment is given. This is a question. For taking the answer, I'll change the color. So everything I do in this color is nothing but the answer. Okay, answer part. So here there is a horizontal force along A and RA. But this is not required since it's a cantilever beam. So we will go directly. So we'll draw true lines. This line is shear force diagram and this is for bending moment. So this is SFD shear force diagram. This is BMD bending moment diagram. So first, to understand this, what I'll do is I'll take a section. I'll take a section, any section, okay, say XX at a distance of X from this particular edge E. That is, first we'll start from the right hand side, that is section DE. See, in the section DE I'm taking, so this is the section I have cut. Section means, assume I have cut there. I cut a section at a distance of X from a load 500 newtons. Okay, this is how it looks actually, correct? So here, when we consider this, what is the force over here? Force is what? If you go to the size signature, we have just learned, right? Assume you are going in the left and coming on the right. This is positive. So we are considering the right section. So right section, it is coming down. So this will be what? Coming down. So this will be positive. That is plus 500 newtons. Now similarly, we can check with moment. So moment will be what? When this load acts down, so what happens? This bends, this sags, and sagging is always negative. That's why minus 500 into X. Now here if you see here, if I take it, the value of X equal to 0, that is the length. Here what is the length? X equal to 0.5. Here what is the value? X equal to 1 from this distance. Here it is X equal to 0.15. This is X equal to 2. Total distance, total length of the beam is what? 2 meter, that is 0.5, 0.5, 0.5, 0.5. At this edge, the length at the edge is 0. Similarly, at this edge, that is at D, it is X equal to 0.5, C X equal to 1, B X equal to 1.5, A X equal to 2. Now we are taking which section? Section DE. So section DE, that is force at D as well as E, it remains same 500 newtons because there is a no multiple of X. But if you see here the product is multiplied with X. So we'll find for moment at E and moment at D. Moment at E, what is the value of X? X is equal to 0. moment at D, what is the value of x? X equal to 0.5. So when a 0 is multiplied with this moment, this is minus 500 into 0 is what? 0. So 0 Newton meter. Similarly here, when I multiply 0.5 with 500, what it gives? It will give half. Half of 500 is what? 250. So this is 250 Newton meter. So let us go back here. This is what? Shear force diagram. What at force D and E, what is the load? 500. 500 is positive or negative? It is obviously positive. So this say 50, 100 and so on, so on. Say this is 500. Okay. At E, it is 500. At D, also it is 500. So what we'll do is I'll join this. So now the pointer is over here. Okay. Now I'll go to moment. Moment at E. This is E, right? At E is 0. So this is 0. Whereas at D it is minus 250, right? Minus 500 into 0.5 is nothing but minus 250. So minus 250 means on the downside, say minus 250 is here. So now I'll join this. So this is 250 Newton meter. This is 0 Newton meter. And this is 500 newtons. So this is how we go for section DE. Correct? I hope this is understood. Now, after doing section DE, we'll go to section CD. So when we go to section CD, now let us go to section CD. So section CD, again what I'll do is I'll assume a section XX somewhere in CD. So when somewhere is CD means assume this is here. So how it will look? If you take the right hand side, D and E will come into picture, correct or not? So when I take XX at in between CD, so the D will come with 800 newtons and 500 newton will also come in. At what distance? At a distance of, this distance was how much? At a distance of X, right? We don't know because I have taken randomly one section anywhere in between CD. So, but we know the distance between D and E, that is 0.5 meter. So what will be this distance then? What will be the distance between this? This will be X minus 0.5, correct? So now we'll go with checking the force and moment. So force 500 is coming downwards. We are assuming the right hand side. So the signature is what? This, correct? So right hand side loads coming down, falling down is always positive. So this is plus 500. This is plus 800. This will be plus 1300 Newton meter. Similarly, when we go for the moments, it will be minus, right? Opposite. So this is minus 500 into X minus 800 into X minus 0.5, right? Now here, what is the value here in the first case? F, there is no multiple of X. So force is common and constant for all sections C and D, that is 1300 Newton meter, right? Now here moment, there is a multiple of X. So we need to find for which section we are talking. We are section talking CD, that is we need to find the value of M at D and M at C. M at D is what is the value of X? X is equal to 0.5. At C, What is the value of x? X is equal to 1. So now when I put the value of x equal to 0.5, that is minus 500 into 0.5 minus 800, 0.5 minus 0.5 get cancelled. So here we get it minus 250 Newton meter. Similarly, when I put the value of 1, so it will be minus 500 and here it will be 800 minus 0.5, that is 400, correct? So finally here we'll get it 500 and 400 minus 500 minus 400, that is minus 900 Newton meter. So in the force you can see this is 1300, this was 500, it have moved to 1300, so 1300 will be little bit up, say 1300 is here and as well as 1300 is here as well, so we join them. So the pointer goes this way. Now the pointer is here. So this is what? This is 1300 newtons. Similarly, when we go to this I should write it. This is E, D, C, B, A. So no confusion. So M at D is how much? Minus 250. Yes, it is there. C is 900. So 900 should be little more. Say 500. So 900 is here. Correct? So this is 900 Newton meter. Okay. So this is again shear force and bending moment for section CD. Now let us go for the other section. So now I'll take section
any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free AMC.